Okay, on this lesson, we're going to be looking at the transformation rules. We've already covered them before, but we're going to be reviewing them. So first thing we're going to do is we're going to be given the verbal description. We're going to be given the original parent function, and then we're going to have to come up with a new equation, and then also writing it in function notation. So looking at the first one, it says it's translated up 5 units. So I'm going to go ahead and write my G equation first, and then I'll go back to function notation. So since we are starting with 10 to the x, we need a 10 to the x in our equation. And then we're going up 5, so outside of the exponent, we need a plus 5. Now, on function notation, you are using, instead of 10 to the x, you're going to use f of x. So I'm going to have f of x instead of the 10 to the x, and then I'm going to add 5. Okay, so looking at the next one, we're going to translate down to, we're starting with absolute value. So I'm going to write my g function first. So I need an absolute value of x, and then I'm going down to, so outside of the bars, I need a minus 2. So now in function notation, instead of absolute value of x, we're putting f of x. So right here, I need an f of x, and then I need the minus 2. Okay, looking at the next one, we're going right 3. Remember, when we have a horizontal shift left and right, it's always the opposite. So we're starting with square root of x. So under the square root, we're going right 3, so you would think add, but it's the opposite. So minus 3. Make sure that you put it under the square root. And then, instead of f of or square root of x, we're putting f of x. So I'll need f, but now, since I'm having to put minus 3 under the square root, I need the minus 3 inside the parentheses with the x. Okay, so the next one, we're going left 8. We're starting with rational. There's a fraction there. If I go left 8, I need to be changing my x. So I need 1 over left. We're going to be doing the opposite. So we're going to add with x. X is in the denominator, so I need that plus 8 in the denominator with that x. And then instead of 1 over x, we're putting f of x. So I'm going to have f, and then in parentheses, I need x plus 8. Next one, we have a vertical stretch. Vertical is always on the outside, so vertical stretch by 6. So when I write my G, it goes in the very front. So I need a 6, and then I need the 2 to the x. This is exponential. You could also, if you want to, put parentheses around it, so however you would like to write it. So whenever you write it, this is f of x, so the 6 needs to go in front. So 6 and then f of x. Okay, so the next one, we have a horizontal that goes on the inside, and it's always the opposite. So horizontal stretch by a factor of 3. We would have g of x equals, inside the absolute value bars, instead of 3, we're going to do the reciprocal, so 1/3 x. So when I write f of x, I need 1/3 x inside the parentheses on function notation. So remember, horizontal, whether it be a stretch or a compression, it's always the opposite, so do the reciprocal of that number. Next one, we have vertical. That's on the outside. Compression of 1/4. This time we're starting with cube root of x. So I need a 1/4 outside of the radical, and then don't forget your index cube, and then so cube root of x. When I write my function notation, I need the 1/4 on the outside, and then the f of x. Next one, we have a horizontal compression of 1/5. Remember, it's the opposite here, horizontal, and it goes on the inside. So I'm going to have g of x equals, I need x cubed. So in parentheses, instead of 1/5, I need to do the reciprocal, which is 5, and then x cubed. So 5x needs to be in parentheses, and then the cube needs to be on the outside. So whenever I write my function notation, I need f and then 5x on the inside. So if you've noticed on all of these function notations, you should not have anything besides f of x and then your transformation. So you don't need exponents, you don't need radicals, fractions. All you need is the function and then whatever the transformation is. All right, we have a reflection about the x-axis that always goes on the outside. So if I look at my parent function, we have a natural log of x, so I need a negative in front, and then natural log of x, so I need a negative and then f of x for function notation. Reflection about the y-axis always goes on the inside, so it's a negative. So I wrote f on the last one, my bad. So I have g of x equals, and then under the square root I need negative x. So when you write function notation, I need negative x inside the parentheses. So anytime there's a reflection, it just puts a negative in either in front on the outside or on the inside, based on which axis it's reflecting over. Okay, so all of this is a review that we've covered this entire year. So now now we're going to be given the parent function, the new function, and we're going to have to come up with the verbal description and then the function notation. So we're given the parent function, we're given the new function. If you notice, the change is there's a 6 on the inside. So on the inside, that's a horizontal. And it's the opposite, so 6 reciprocal of that would be 1/4, so that would be a horizontal compression of 1/6. Function notation, so I'm going to write f, and then inside is a 6 and an x. So there's your function notation for square root of 6x. Next one, we have absolute value of x, and then we're putting a negative on the outside. So that is a reflection over the x-axis. So that would just be a negative f of x for the function notation. Next one, we have the parent function x cubed. The change is we're putting a 7 in the front. So that would be a vertical, and since it's greater than 1, that's going to be a stretch by 7. So you only do the reciprocal as if it's in the inside, like this first one that we did here. So that 7 goes in front of the function notation f of x. All right, and this last, two more. Okay, so then we have e to the x, exponential, and then notice in the exponent, we now have x minus 4. So anytime it's in the exponent, that would be a horizontal shift, and it's always the opposite. So this would be a shift right 4. Okay, so then when you write your function notation, it's inside parentheses because it's a horizontal shift. So it'd be f, and then in parentheses, you're going to put x minus 4. All right, last one. So this one we have log base 2 of x is our parent function. Then we have a log base 2 of x, and then minus 1. There is no parentheses. So if this was a horizontal shift, there would be parentheses, but there's no parentheses, which means there's a vertical shift. Since it's minus 1, this would be a shift down 1. So on your function notation, you have f of x, and then you have minus 1. Okay, so again, this is a review of everything that we've covered with the transformations. Make sure that you are using this time now to finish up the practice and make sure you turn it into the box. If you have questions, then go ahead and turn it in and we'll talk about them next week.